Recent studies indicate that the interstellar visitor known as 3I/Atlas is remarkably hefty and much bigger than anticipated. We'll jump right in to explore the latest discoveries, the developing hypothesis, and the path this cosmic wanderer has taken across our solar system. Music, just how large is 3I/Atlas? Determining the true size of a comet proves tricky. The main hurdle is distinguishing the solid nucleus from the fuzzy envelope enveloping it. When a comet nears the sun, its icy components sublime straight into vapor, hauling along dust particles that create the signature tail or coma. As a result, the comet can seem much bigger and more luminous than its actual rocky center. A group of researchers from Harvard, headed by Richard Cloutier, Avi Loeb, and Peter Verez, examined data on 3I/Atlas gathered from May 15th to September 23rd by 227 observatories around the globe through the Minor Planet Center. They contrasted the object's real path with the one predicted solely by gravitational forces. Their analysis revealed a small yet detectable nudge, under 15 meters per square second. Typically, comets exhibiting vigorous outgassing experience a gentle thrust from the blasts of released gases. However, for 3I/Atlas, the detected non-gravitational pull is unexpectedly minimal compared to the visible activity. This implies the core possesses sufficient mass to barely budge under the influence of those outflows. Based on this, the team calculates the comet's nucleus to mass more than 33 billion tons and span about 5 kilometers across, excluding the encircling coma, making it 3 to 5 orders of magnitude heavier than previous interstellar intruders. Loeb points out that, considering the presumed density of such objects and the prevalence of heavy elements in interstellar regions, we'd expect to have encountered plenty of smaller ones by now rather than hitting upon something this enormous first. But that's not the case, positioning 3I/Atlas as a striking anomaly. Loeb goes further, pondering a bold possibility. The thing might be artificial in origin, pointing to its surprising bulk, the precise alignment of its route, and reports of nickel detected without accompanying iron as intriguing clues. NASA experts, though, advise restraint. The consensus holds that it's probably a natural formation. From the images, we can see this object is active, meaning there's a coma surrounding the nucleus, which confirms it's indeed a comet. On another front, certain researchers aren't just questioning what 3I/Atlas consists of, but pondering its potential role. Astrophysicist Suzanne Pfalzner's concept is straightforward yet compelling. 3I/Atlas could act as a seed for planet formation. But how might a rogue chunk from a distant star system trigger the creation of a whole world? Let's walk through it. Picture a fledgling solar system, with a newborn star at the heart of a vast disk of dust. In this setup, minuscule rock particles eddy about like mist, gradually aggregating into gravel. Over time, they build up into rocks and eventually planetesimals, the building blocks of planets. Eventually, these swell large enough to attract additional stuff. It seems simple, yet there's a major flaw in this narrative. Protoplanetary disks endure only a handful of million years before the gas dissipates. That brief interval appears insufficient to account for the assembly of behemoths like Jupiter and Saturn. Consider an alternate picture. An interstellar interloper plummets into the disk, arriving as a preformed hefty core. Rather than building from scratch out of fine particles, the disk now boasts a sturdy foundation that can swiftly draw in nearby gases and debris. Thus, this extraterrestrial arrival might accelerate planetary development. Pfalzner's models back this up. She discovered that more massive stars excel at snaring interstellar bodies compared to their dimmer counterparts. And indeed, gas giants tend to orbit larger stars more frequently. The alignment of model and reality is impressive. Should this hold water, then interstellar travelers such as Oumuamua, Borisov, and 3I/Atlas aren't mere passers-by. They could be the catalysts that kickstart planetary births. Some may have anchored gas giants in remote systems. Others might have contributed to our own solar system's formative days. It's a daring notion, unverified for now, much like Loeb's. Probing interstellar objects is inherently challenging. They show up abruptly, zip past at high speeds, and fade into obscurity. Yet this instance, we've spotted it early, putting us in a strong position. Advanced tools could at last reveal its essence before it slips away, instead of mere post-visit speculation. The ESA is gearing up Mars Express and the ExoMars Trace Gas Orbiter to monitor 3I/Atlas during its close approach to Mars in October 2025. These probes intend to snag unprecedented visuals and measurements of such an outsider. Be it from Martian orbit or Earth-based scopes, the next few months promise a unique chance to scrutinize an interstellar object up close. Astronomers have marked out several crucial dates on their schedules, key events to track as this cosmic traveler speeds through our solar system. On October 3rd, 2025, the Mars encounter arrives. Shortly after dawn above Val Marinis, the comet will sweep by the rusty world at a distance of just 18 million miles. Orbiting probes like MAVEN and Tanwen-1 will catch sight of its hazy envelope beginning to shimmer with a subtle pink hue in the Martian sunrise. Then, on October 29th, 2025, it hits perihelion. For weeks afterward, 3IA Atlas will whip around the backside of the Sun, dipping in close at 1.36 astronomical units, or roughly 130 million miles, from the solar surface. That's when its velocity tops out around 152,000 miles per hour. Right then, the comet vanishes from ground-based observatories, obscured by the Sun's intense light. Yet, missions stationed at Mars and the L1 point will maintain vigilance as bursts of gas burst forth from the newly heated surface. By December 19th, 2025, it's time for the Earth closest approach. With its tail now stretched out completely, 3E Atlas will glide by our planet at a safe 170 million miles away. Not near enough for spotting without aid, but sufficiently close for instruments like the James Webb Telescope and Rubin Observatory to scan its envelope for signs of isotopic signatures. Finally, March 16th, 2026, brings the Jupiter flyby. The interloper will zoom past the massive planet, 33 million miles over its stormy atmosphere. Should NASA greenlight a last-minute trajectory adjustment, the Juno probe might veer over to collect bits of the comet's particle trail, offering our only direct glimpse at stuff that originated far beyond the Sun. Following that, 3 Atlas will arc away into the depths of interstellar void, bequeathing vast archives of information and plenty of puzzles. What's your take? Share your ideas below. I'd really appreciate reading them. If this video caught your interest, think about joining as a channel member to back our efforts. And make sure to hit subscribe on Territory. After all, this is your universe. Music.